It's a photogrammetry, aerial photogrammetry. So swath distance and swath distance along the flight line, instantaneous field of view. You can call it as instantaneous field. How much angle covered divided by number of pixels in that direction. Same y direction also. That's it. So now is aerial photographs, vertical, tilted and oblique. So vertical is like this. We draw two-dimensionally. Okay. So this is exactly optical axis. What is an optical axis? It's a camera axis only, but why it is called optical, not in a vertical axis? Optical lenses also there. You add optical lenses. What is mean by optics is, if you're using the visible lens, see visible light, we call it as optic. Any lenses or anything uses for the visible light, we call it as optical. Okay, that's called optical. So optical lens, optical axis exactly perpendicular to the ground axis, then it is called a vertical photograph. So otherwise, if it is see small tilt, small tilt, small tilt happen, maybe 2 degrees or 3 degrees, 3 degrees up to less than 3 degrees. Less than 3 degrees, if the camera is tilted very small, so why is there less than 3? Maybe unwanted or uninterested, it's a theoretical. Maybe everything has some error. If the error is below 3 degrees, we call it as a tilted photograph. But reality, these are the photographs we get, not these photographs we get. We discussed everything in the theoretical form, but reality we will get just a small tilt, at least 3 degrees, below 3 degrees. Maybe chance are there. It's a wind. If you take a photographs through airplane, wind will slightly changes. Are understood? Slightly. So I can't exactly represent very slightly, but okay. So this T less than 300, you can call it as a tilted. So oblique is, sorry, so oblique greater than 3 degrees of tilt is there. This is called oblique photographs. So these are also useful because we get more information. We get more information because it covers more length, but details are missing. Details are missing. Okay, but this is we just unwanted. This is wanted. This is wantedly we taken this oblique photographs, but this tilted unwantedly, small chances of error are there. So we will get like this. Okay, so if you see the images are there. These are the lenses. Lens of camera, this lens is called optical lens. Optical lens. This is a tilt, low oblique. So okay, low oblique, high oblique also you can take it, but tilt is very less than 3 degrees. That is called tilt photograph. It's low oblique, high oblique. You said that like this. Okay, you can take 4. So we can't take less than 3 degrees. You can't pronounce as oblique. No, it's just a tilt. Okay, this is the projections. Just observe it. Otherwise, if you take in a flight, just observe it. Observe it. Vertical photograph, it will covers tilt photograph or object photograph. Maybe it will cover like this. Maybe it will cover like this. Something. Oblique, you can take this. See, oblique. The camera mounted on the aeroplane. Position is shifting. Position you can take. You can place like this. You can get the oblique photographs. Okay, so that's it. These are the photogrammetry. See different types of aerial photography. Now we will go through the exact photograph. Exactly how the photograph will capture, how not how, what is photograph. everything we discussed is vertical. Tilted are those are the derivations are too much hectic. Okay, see later. Vertical photograph. Vertical photograph. We already know it. These are the axes, photographic axis. You see, maybe it's a point. Maybe that's much land. See, I understood. I think once again I will draw optical axes are different. This is a plane. These are the x-axis. So this point, see this point. Maybe you can talk small a, small b, small c, small d, small a. Where is small a? We draw. Sorry, I draw from this axis. Okay. So I will draw. So, okay, same thing. See this a, this is a, this d, a. Exactly, it's b. Where it is? I draw something. Something is a b is exactly line no? A and b. These are the plane. So that is the problem. You have to draw three-dimensionally. That is the too hectic process. I am not a good drawer, painter or anything. So I can't exactly draw a picture. So otherwise I will strike out everything. I will strike out everything. I will draw something different. Once again I draw like this now. What is this? What is this? Mhm. See, I can't draw. I'm not. I'm in poor in drawing. It's okay. No problem. No problem. We'll shift the diagrams. We can shift the diagrams. Shift it. How can we shift it? See. See, there it is. Somewhere here. Okay. Okay. No problem. See. The picture is see. So this is the land. This is the picture. And ఏం కనిపించట్లేదు ఎవరో ఏలు పెడతారు ప్రజెంట్ స్క్రీన్ ఎవరో కొట్టేశారు So see it. See, it's a vertical photograph. See, it is a focal point, focal point, focal point. Exactly. See, this is a negative image. It's a negative plane. It is a positive plane. We taken it as a positive plane. There is no lens at all. There is no film at all. With just understanding purpose. Exactly replica of negative image. Into upside down, we will get good image, positive image. That's why we taken this exactly the length of exactly same focal length. So taken this is a focal length. Okay. So focal length. See, observe it. You will get a exactly negative image. This point comes to this point. This point comes to this point. These 2 points will get these 2 points. Understood? It's a camera assembly, perspective center or executive station, exposure station, negative image for optical length. It's a focal length. So this axis, this point is principal point. You can call it as exactly. It's a principal point. You can, this is the optical axis or principal axis, anything you can call it as principal axis, optical axis. So if you observe it, inside of the points, see inside of the points, this is a, if you taken, this is also a field. This point, somewhere this point, where it appears, it appears through this lens. This lens. Understood? Exactly. That's it. So this point, somewhere here, this point, somewhere this point will appear to this lens. This lens. Okay, this lens. Opposite, exactly negative image will come. That's it, na? So it is a negative image, it's a positive image, and you can also observe it's a it is also axis. It's a photo axis. Photo axis. This is the ground coordinates, ground axis. If you take in coordinates also, this is a x, this is a y. So this is x, this is y. Coordinates, ground coordinates, xa, ya. In this same you can concentrate small, small. So x small a, x small, yb. It's not a, ya, yb. Some point is called a, it is also a. It's xa, ya. Coordinates. Exactly negative image will come. Okay. So this is a exactly vertical photograph. Vertical photograph. Okay. This is called vertical photograph. How the photo is filming or captures. It is a positive image. This is a principal point or focal point or perspective center, exposure center. It is called optical axis. Okay. Got the picture? So I can't draw. Okay. If I draw, you can't exactly get the details. It's a good idea. So that's it. That's the first photograph. So next also I will take another picture. Another picture is that's it. So okay, another picture. Okay. So see pictures. See the pictures. So this is a x-axis and y-axis. See, this is x, this is y, this is also same, this is also x, this is also y. Some x and y are your choices. Okay. So and also see, these are the fiducial marks. These are the important. These are the fiducial marks. Edges fiducial marks are there. Sir, why it is fiducial mark? So we have to assemble every photo, na? We have to assemble every photo. How can we identify exact the details of this photograph and this photograph? Everything is a overlapping, na? Overlapping. That's why we just mark it. Those are the fiducial marks. Those are the centers to assemble every photograph. That's why these details are somewhat better. I think some, I don't know exactly. That's the mark. So that's called fiducial marks. Okay, to assemble every photo one by one. Okay. So see, these are the principal point. So I will say once again. Previously I said what I said. Maybe every time the exact photograph is not possible. maybe some tilt is there, exactly. If it is, see, it's not chance, maybe it will come tilting, very small, 3 degrees will tilt. So that's why see, the principle, see what is that, is where it is, the optical axis, where it is, this optical axis, see, red color, this optical axis doesn't meet exactly, the optical axis point doesn't coincide with the exact center of the photograph. Because what is, sir, why is, sir, why means exactly, maybe small tilt will happen, 2 degrees, 3 degrees will happen. That's why the principal point doesn't coincide exactly the center of the photograph. 2 degrees, 3 degrees will come, but we don't discuss those things. We discuss only theoretical. If you take and tilted also, you have some small exercise will have to do. This is called principal point. Otherwise, theoretically, this is a principal point. Theoretically, this is, but small tilt will happen every time, 2 degrees or 3 degrees. 2 degrees, 3 degrees means what? How small, you know it. So this is a principal point. This is a principal point on the ground. Otherwise, in reality, this is the principal points in reality. But see, in theoretically, those are the exact. But the reality, it's slightly 2 degrees, slightly changes. So now, what is called this axis? Exactly, principal point. So center of the photograph to the center of the ground. What is called? It's called Nadir axis. Where is the Nadir line? It's called Nadir line. Nadir means, you can get the idea of Nadir is gravity. So perpendicular to the gravity line. Perpendicular to the gravity. So gravity line, you call it as a gravity line also. You call it as a gravity or Nadir axis. So it called as a Nadir point. This is a Nadir point. Center of the photograph, center of the ground, it's called Nadir points. Okay. Generally, it's called principal point, but in general, a slight 2 degrees, 3 degrees will change. That's why principal line or optical axis is not coincide with the exact center of the photograph to center of the ground. Small tilt will happen. Okay, that's called Nadir point, Nadir axis. Okay, those are the fiducial center, fiducial marks, negative image plane. Okay, so these are the positive image plane. Positive image plane. See, I said it's a small tilt will happen. It will happen. So tilting axis, small tilting axis. Okay, you can see these require later. Okay, that's it. So how the photographs is taken? Okay, vertical photographs, we discuss negative plane, positive plane, fiducial marks, another point, principal point, Nadir axis, optical axis. Okay, these are the terms, we will get it. Okay, so now the scale will come. Scale. So what is scale? Scale is just, if in a ground, if it is a ground, so where it is, the image here. In the ground, how much the distance between these 2 points? If you see, this is XA, this is YB. So exactly, in reality, see, this is in photograph, this is XA, this is YA. So exactly how much length is reduced to the photograph? Understood? So in ground, the distance between this point, so the distance between this exactly center to this point, how much this center distance to this point? So otherwise, I will write this. So this photograph is this. In reality, this. Okay. So how the distance is varying? Understood? How the distance we can calculate? So that is the scale. How much the scale is reduced to the photograph? How much length is reduced in a photograph? That is a scale. So first we will see. First we can't directly taken this distance from center. We just taken from one station, one axis. Okay. For this one axis, this much distance is reduced to this much distance now. See. So how much it is reduced in one scale? For x-axis, how much is reduced? For y-axis, how much it is reduced? Later we can take the coordinates. It has the coordinates of x capital A, y capital A. You get the coordinates of x small a, y small a. So automatically you will get the point distance from 0 0. Otherwise you can get the distance of another point also. If you see another point somewhere here also, it has some xb yb. In the photograph also it will come like this in this zone, e zone. Okay, so once you got small a, small b, small b, small b, xa, xb, yb, you will get the distance in the ground exactly from the photograph also. But how much it is reduced in a photograph, we have to take it. So once you calculate the how much it is reduced in a photograph, you can directly take the distance between any 2 points on the ground from the photograph also. Okay, are understood? So that's it. That's the our idea. So first we will go to the scale of the photograph. Scale. Okay, scale of the photograph. So how I will, so I will show once again. I have to draw a photograph, but I can't. So that is the best idea to take a screenshots and we'll get it. Okay, wait. సార్ చెప్పండి. ఏం చేస్తున్నారు? ఇందాకేమో ప్రజెంటేషన్ పెడితే ఇప్పుడేమో ఎవరేం చేస్తారు? ఎంతసేపు అయింది? ఏమైంది? రావట్లేదు అసలు, స్టార్ట్ కావట్లేదు. అరే ఓకే, వెయిట్. ఏదో చేశారు. కాంట్ జాయిన్ దిస్ వీడియో కాల్, సమ్మన్ ఇస్ ఆపరేటింగ్.